I tell you, that is very loud on Zoom. Well, it doesn't matter. I mean, we can tolerate it. It's only one sentence, but by the time the whole, uh, all the classes are over, we'll finally have figured out how to do it. Okay, good. Uh, Good morning. I think they're lost in the fog. Good morning, Richard. I'm going to talk about that at the very end. You know, all my patients used to ask me for the magic pill. They didn't want to go to the gym. They didn't want to diet. Give me a pill, doc, that'll make me lose the weight. Well, they've got their wish. Good morning. So were you lost in the fog also? They're complaining about the fog. The fog outside. Okay.
You want me to make my little spiel now?
What?
I'm starting to make my little spill.
Yeah, you can make your spiel, sure. Absolutely.
Welcome, welcome. Zoomers, please stay muted. Um, People in the room, if you have a cell phone, please silence it. Would be greatly appreciated. And Joe is going to talk about food today.
Okay, well, food is more high tech than you think. So when we look at food, we have seasonal, which means we used to get fruits and vegetables in the summer and not in the winter. And if we look at the types of food we have natural food as it grows, we have cooked, preserved food. And in the old days, you got food that was produced locally. Now we get food that's shipped in from all over the world, really. And we figured out how to store food in cold storage and under the conditions that keep fruits and vegetables, in good shape for relatively long periods of time. We also have hybrid foods now, and now we have genetically modified foods. Processed foods include anything we do with food. So if you cook it, it's considered processed. And then, of course, we have the hyper processed or the ultra processed, which is food that's really been treated to the point where sometimes we don't even recognize it. So let's see, where's my. Okay. Oh, there we go. So if we look at our basic food types, we have our seasonal vegetables and fruit, and we have foods that can be stored, like the root vegetables, potatoes, apples, carrots. And then we have grains, which we can store, so they're available year round. And then, of course, we always have fresh meats, poultry, and eggs. But the real advantage and the real improvement was to preserve food. And so the original preservation methods were fermentation. And so we have sauerkraut, we have kimchi, but also cheese to preserve milk, wine, and beer. The big improvement in foods was we learned how to can foods to preserve it. And then more recently, frozen foods, freeze-dried, which classically is coffee and yeast. And then we're going to talk about irradiated foods because that's probably the future. And that's going to be one of the ways in which we can preserve food safely. I'm going the wrong direction. Canned foods are a relatively recent development. And, we've had dried, salted, fermented foods way back in recorded history. But treating them in airtight containers didn't come along until around the 18th century. And the real stimulus for preserving food was Napoleon, who needed a means of feeding his army. So in 1795, he offered a reward for anybody who could develop a safe, reliable method of preserving food for his army. And a fellow named Nicholas Appert took the challenge. It took him about 45 years, but he figured out how to preserve food in glass, where you heated it, put paraffin on top, and then sealed it. And that's a method by which my mother used to preserve the cherries from the tree that grew in the backyard. You sterilized the jars, you poured in these boiling hot cherries, you had melted paraffin, which you put on top. And if you did everything right, you didn't have any bacteria active there, and you could preserve that for years. Well, apparently it's not considered as safe as we thought it was. Whoops, what happened? Okay, so the real improvement was the so-called double seam closure. When I was in college, I worked in a food factory, and I saw the cans as they came before the product was canned. And the can has a flange on it on the top. The lid is oversized to the point where the flange on the lid goes over that flange on the can. And then a machine folds the flange from the lid over so the two flanges are together, and then both are folded again. So it's a double seam closure, and this is what we use today. So if you look at your can, you'll see that this is the way it's done. It hermetically seals the can, and it works. And so there haven't been any improvements on it. It's a process that's been around for quite a while. Frozen food is relatively recent. The reason that all the frozen food early on was bird's eye is because Clarence Birdseye figured out how to do it. And he developed the first frozen food in 1930. And it was known then that if you freeze food slowly, you get ice crystals. This ruptures the cell membranes, so when you thaw that out, it's kind of mushy and doesn't taste very well, and the texture isn't right. So Birdseye figured out that if you quick freeze it, or what we call today flash freezing now, and you quick freeze something to 0 degrees, it preserves it, and it preserves it quite well. So if you have a 2-inch thick steak in 90 minutes, it'll preserve well. Fruits and vegetables take only 30 minutes. And then we got freeze-dried food. And you can't freeze-dry everything, but a lot of fruits and vegetables, breads, cheese, eggs, chili, can be freeze-dried. The classic, of course, that we're all familiar with is instant coffee. And those of you who bake and use yeast, the yeast that you buy is freeze-dried. I put Tang up there because that was a freeze-dried, I won't call it orange juice because it wasn't orange juice, it was a substance that apparently the astronauts took into space. It wasn't very good, and even though it was supposed to be orange juice, it really wasn't. But some foods you can't freeze dry. So if there's a high water content, like most of your vegetables, your tomato, your lettuce, your cucumber, they don't take well to freeze drying. High fat foods, nuts, butter, oils, they don't do well, and the starches apparently don't do well. But irradiated foods are something you need to know about. It's been treated by ionizing radiation, usually by gamma rays. Cobalt 60 is a good source of them. And what it does, it kills everything. All the bacteria, any things that would contaminate the food. And it's safe. The food does not become radioactive. It doesn't glow in the dark, but it does extend the shelf life. and it reduces the risk of food poisoning. It reduces the need for pesticides and preservatives and antioxidants, and it reduces the risks of importing or exporting insect pests. Those of you who have been to Europe, maybe you've seen a product called Parmalat, which is milk. It's on the shelf at room temperature. It's good for 6 months at least. That's been irradiated. And they do a lot of it in Europe. They don't do a whole lot here. We got to talk about plants because all the oxygen in the air and all the stuff that we eat, especially the carbohydrates, they all come from plants. And so it's the chlorophyll pigment in the plant, particularly in the chloroplast in the plant, that does it. And sunlight provides the energy for the chemical reaction. And what we're doing is converting carbon dioxide and water to oxygen, and the carbohydrate is glucose. So the green plants are the source of our food and our oxygen. There's some things that grow in the dark, like mushrooms. And those of you who like Belgian endive, it's an interesting plant. The plant has to grow in the sunlight, and then when the leaves become dormant and you just have the roots left, you then put that in the dark. And what comes out is Belgian endive. If you turn on the light, Belgian endive will turn green. You don't want it that way. So it's one of the few things that is, you might say, is a little bit processed. But it's the chlorophyll and the chloroplasts and the green plants that really do all the work. So here's the critter that does it, the chloroplast. It's got an outer and an inner membrane. It's got various structures inside, but it's the thylakoid, or this little round blob, that really does the work, because that's where the chlorophyll is, and that's where the reactions are occurring. So what actually is occurring? Well, the chlorophyll is absorbing the energy from the sun, and it's doing two things. It's making ATP, which is a molecule that stores energy, and it's reducing nicotine adenine dinucleotide phosphate. In other words, we used to call it DPN, now they call it NAD. But what it's doing is putting a hydrogen on it. And that hydrogen, together with the ATP as an energy source, is taking the carbon from the air and reducing it to give it your organic carbon compounds. So it's the assimilation of inorganic carbon into carbon. Now the reaction, as you see, is 6 carbon dioxide and 6 water give you 6 oxygen and a molecule of glucose. And that's the reaction that occurs. So it's the plants that make organic carbon compounds. So organic chemistry, which everybody struggles through, is really the chemistry of life. And if you take a cube of sugar and you put a match to it, you'll eventually release all the energy and you'll get carbon dioxide and water. But we don't run at that temperature. We run at a relatively cool temperature. And so to break down the glucose, we have to do it in short steps. And we have chemical catalysts called enzymes that do this. Now, early on, the chemists didn't know what these catalysts were, but they knew whatever was happening in yeast. And in French, enzyme means in yeast. So there was something in yeast that did this, and then they figured out years later what these particular compounds were. But by doing this in stages, you can release the energy at body temperature, and this allows us to get our energy. Interestingly enough, there's one set of metabolism, whether you're a plant or an animal or anything, that takes this state of glucose down to the energy, and finally we reduce it to carbon dioxide and water. So we have sugar metabolism to get the energy we need. Now, if we look at the types of plants that we get this from, we have those that are normally present in nature, the cereal grasses, our wheats, our rye, barley. And then we have some plants that are normally hybrid in nature. The classic, of course, is corn. That's a hybrid in nature. And then humans got into the act, and we selectively bred plants, made the ones that we wanted. And then we went to modern hybrids, where in addition to selective breeding, we started monkeying with the molecules. So we get genetically modified organisms and plants. And there's more of them than you think. There's a lot of genetically modified crops. And these are the ones that you deal with every day. Our corn has been genetically modified. Specifically, the sweet corn now has the shrunken S gene, which allows it to be sweet. And corn normally, the sugar corn that we eat, is pretty sweet, but it loses its sweetness very rapidly. And they've worked hard to try and get corn that maintains it. Some years ago, as an experiment, I grew corn in a small patch. It was a sweet corn, and we had the water boiling before we took the ear off the plant. So there's 1 minute from the plant being harvested to the ear in the pot. That ear was so cloyingly sweet you can't imagine. So sweet corn, if you get it in a farmer's market where the farmers picked it that morning, and you'll be in for a real treat. The corn that we get in the store, the longer it's there, the less sweet it gets. And then we have soybeans, which of course are genetically modified, cotton, canola oil, which is your normal oil, alfalfa, sugar beets. All the papaya that you get is now genetically modified. The ungenetically modified papaya is long gone because the fungus got it. So every papaya you see is genetically modified. We've done that with squash. We've done it with apples. We have a potato, and we're also doing it now with animals. We have a salmon, which is genetically modified. So if we look at these plants, we start with corn. We're used to these very large ears with lots of kernels. But way back in the 1920s, some of the ag colleges in the US decided we're going to get to the parent of corn. And they did. It's this miserable little plant called teosinte, which has very few kernels. The kernels that it does have are hard as rocks. And they'll pop, but they're not much. And from then on, they hybridized, but they got to the original parents, and that's the parents of all the corn that we have today. So all of the corn that we have, whether it's grown for animal feed or ethanol or eating, is all from those experiments way back in the 1920s. If we go next to the tomato, originally it was called a poison apple, and the reason was because the people who ate it usually sliced it, put it on a pewter plate, and the acid in the tomato leached out the lead. So basically they were getting poisoned by the lead. But the tomato that we have today is very highly modified. The original tomato goes way back when, and it was kind of sour. And tomatoes have been hybridized for all the wrong reasons. To withstand shipping, to look good. Early on, they were hybridized to withstand the various fungus that would attack them. The one thing they were not hybridized was for taste. And a couple of years ago, the Ag Department at University of Florida did just that. They said, let's make a tomato that tastes good. And so, unfortunately, it's not available commercially. You can't buy it in Publix. You can't even buy the seed. But if you give the department a contribution, they will send you a couple packets of this tomato seed. And I have to tell you, my daughter grew it. It's a very good tomato. So how do we do this? How do we mess up the genes in the tomato plant? I'm not going to go through this just to show you that it's a bit complicated, but you take the gene that you want from a bacteria, you have to tag it so you can identify it. You somehow put it into the plant that you want, and you grow the specific plants that have this gene incorporated into it. And you do that because of the tag that you've put to it. And then you finally wind up with a plant that has the gene incorporated in it with the characteristics that you want. And the characteristics that you want it to be resistant to fungus and other parasites. But maybe you also want it to be durable. You want it to taste good. And so there's a lot of things you can do to modify the plant. Well, if we next go to the apple, they've been around since antiquity. They haven't always been sweet. The original apple was kind of sour, and we have modified that tremendously, and mostly for the better. So most of your modern apples are really very good. We've modified them so they grow in climates where they wouldn't normally grow, namely further north, where the growing seasons are short. Next, we come to the carrots, and carrots have been around since the days of the Roman Empire and the ancient Greeks, but it wasn't the carrot we have today. It wasn't this big, juicy yellow or orange structure. They had forked roots, they were purple, and they were completely different than what we have today. So today's carrot has been modified considerably. The real success story is the banana, and that's been around for a long time, but if you look at that picture with all the seeds in it, that was the old-fashioned banana, full of seeds, kind of pithy, and not the nice yellow seedless banana that we enjoy today. Now, the banana that we have now is the Cavendish. It's a monoculture, and it's endangered. The banana that you had previously was the Gros Miguel, or large Michael, big Michael. It was a bigger, sweeter, supposedly had a more of a banana taste, but it's history because the fungus got it. And now the parasites are beginning to attack the Cavendish. So unless they can develop a genetic mutation that's resistant, enjoy your bananas while you can. Next, we come to the eggplant. And we see these big, beautiful purple eggplant. And I always wondered, why is this thing called an eggplant? Well, because the old eggplants were small and round and looked like eggs. And so that's where the name came from. But it also has been selectively bred, and now we have these large, beautiful eggplants that we enjoy today. But it's an ancient fruit, an ancient vegetable. Same thing with the watermelon. The watermelon is not the watermelon of ancient days. It's been around since antiquity, but it was full of seeds. It wasn't necessarily red inside, and it wasn't very big. And now we've got seedless watermelons. You can grow them in any size, and now we have them in different colors. You can get orange watermelons, you get red watermelons, and it's what we enjoy today. Next, we got to talk about milk and cheese and pasteurization. Now, Louis Pasteur developed this, but it was not for milk, it was for wine. And the problem was the wine was getting corked. So they wanted a mechanism by which they could preserve wine. And he figured out how to do it. It wasn't until about 1924 in the US that we passed a law requiring milk to be pasteurized. And the reason was because cows would be infected with tuberculosis, and you could get TB from infected milk. You didn't get it in the lungs, you got it in the GI tract. But there are a lot of diseases you could get with infected milk: scarlet fever, typhoid, in addition to TB. So there's three ways you can pasteurize something. You can do it slowly, 145 degrees for 30 minutes. The way that mostly it's done, the regular pasteurization, higher temperature, 161 degrees for 15 seconds, and then ultra high temperature, 280 degrees for 2.5 seconds. Now, the slow and the regular will kill most of our bacteria that cause disease, but not all of them. The high temperature kills everything. And so it means that you can preserve foods better. And the high temperature pasteurization is really the equivalent of radiation preserving. It kills all the bad guys. And it means you can preserve food at room temperature and for longer. So it's not just milk and cheese. There's a discussion now about getting raw milk back in. I think that would be a big mistake. And, you know, in Europe, cheeses are not pasteurized, but they're not permitted to be sold in the US. So everything here is pasteurized. Next, we got to talk about GMO animals. First, we attacked the plants, but now we're going after the animals. And so we have a salmon that's been GMO, and we have a pig. And the advantage is with the salmon, it grows faster, and it's, we get a better yield. The so-called gal-safe pig is free of the alpha-gal sugar that's in most meats, and some people are allergic to this. So they've raised a pig which is free of this particular device. They've determined that both these animals are safe to eat and they're nutritious. And so there's a definite advantage. But GMOs are a hot subject, especially in Europe, but they have tremendous benefits. You get more nutritious food, you can get tastier food, you modify it. So your food is now disease resistant, so there's less wastage. You can use fewer pesticides. The main advantage is you increase the food supply and you have a longer shelf life. You can grow these plants and animals faster, and you can put in the traits that you want, make the corn sweeter, make the tomatoes taste better. People are concerned about GMO. They're afraid that we're going to produce something which is not good, something that's harmful, something that will come out of it that we don't want, and that foods are less nutritious. It turns out that all of these so-called objections have not been met, that the GMO food is good for us, it does serve a purpose, and unfortunately we need it because we need to be able to feed the world. And GMO food is the way to go to produce the food that we need to feed everybody. We can increase the yields, we use less pesticides, and it's the wave of the future. We can't afford to ignore a technology that has such tremendous potential. Then we have to look at foods as medicine. And the great success is the so-called golden rice. In a large part of Asia, people are vitamin A deficient. And so they developed a rice that produces beta carotene, or gives you the vitamin A that you need. And it's caused a real revolution. We've also increased the protein content of rice, and we've increased the yield of rice. We've used the bacteria to make some of our medicines, and classically is human insulin, which we get E. coli to produce, so now we have Humulin. I remember when I was younger, we had different insulins. We had lamb insulin, we had pork insulin for people who were allergic. And I remember that every pancreas from every abattoir in the country went to Eli Lilly to produce insulin. Well, now we produce it using bacteria. Vaccines are usually produced in eggs, and we have other biologicals that we produce, and we use the plants to help us do it. We have to talk about processed food. Now, you might say the original processed food was learning how to cook food, but processed food by the Department of Agriculture definition is anything that's not rare, raw rather. So anything we do to food, wash it, clean it, mill it, cut it, chop it, heat it, pasteurize it, cook it, can it, freeze it, that's processed by their definition. So unless you're eating a raw apple, your apple juice is considered processed. And that doesn't mean they're not good for us, they are. And some processed foods, including cheese, fresh bread, smoked and cured meats, salted nuts, frozen vegetables, they're good for us. But maybe we can go a little too far. So if we look at our corn, we have canned corn, and then we have corn chips. That's ultra processed. The apple juice, and then apple pie. The potato, well, you have to bake a potato. You can't eat a potato raw. But then French fries, that's ultra processed. The carrots, carrot juice is good, but carrot cake, well. And then wheat, of course, we have flour, which we have to process the wheat into flour, but then we make cookies. So ultra-processed food, not all of it's bad. Um, it's convenient. If you have commercial bread, you have to put additives into it to preserve it so it has a shelf life. You have to add to it antioxidants and antifungal agents and emulsifiers, so you have a product that has a decent shelf life. The cereal is interesting. Some years ago, the cereal companies decided to add BHA and BHT, which is butylated hydroxyacetone and butylated hydroxytoluene. So if you weren't a chemist, you didn't know what these were. But it was added to the packaging to preserve freshness. They're antioxidants. Okay, then they started adding it to the cereal itself. And people were wondering, hey, what do we know about these compounds? So they did the studies, and they found out that not only are they not harmful, they're beneficial. So now they're purposely added to your cereal because they're good for us. So not everything is bad. We have processed meat. We put nitrates in meat to process it, to preserve its shelf life. And then, of course, we have sweetened and alcoholic beverages, and we have candy. So some of it's good, some of it's bad. So how do you identify ultra-processed food? Well, you look at the list of ingredients. If you can recognize them, probably that's not. If you see a list of ingredients where you don't know what they are, that's ultra-processed. And then if you see a list of ingredients where even if you have a degree in chemistry, you don't know what they are, that is really ultra-processed food. And the classic that I show is Pringles. Pringles was originally put out as a potato chip, and then they got sued by Frito-Lay because there's only 44% dried potatoes in the stuff. And apparently, according to the rules, you have to have over 50% to call something a potato chip. So it's a Pringle, but it's not a potato chip. But if you look at what's in it, it's most of the stuff you will not recognize. Now, to its credit, it's got a shelf life of over a year. But it starts out with dried potatoes. Then you have all these oils: vegetable oil, corn, cottonseed, high oleatic soybean oil, sunflower oil, yellow corn flour, cornstarch, rice flour, maltodextrin, and all this other stuff. They make it in the shape which is higher mathematics, but it's a shape that preserves it from breaking. And apparently when you eat the chip, it conforms with the shape of your tongue, and so it tastes good and it has the right crunch there. But if you get a Pringle that's got like a flavor to it, then your list of ingredients goes up almost exponentially, none of which you will have in your pantry. So besides the sugar, you've got the glycerides, the extracts, the color, the maltodextrin, the various oils. And it's a food that's designed where they're correct when they say you can't eat just one. It hits all the sensors in the brain, so you keep wanting to eat it. It has the right amount of salt and oil and crunch and mouthfeel, as they call it. So if we look at the food that we have today, we have a greater selection and availability than we ever had before. We have foods that are out of season. They come from other parts of the world, but I can remember when I was growing up, you had peaches and plums and grapes in the summer. You didn't have them all year round. So we don't have any real seasonal fruits and vegetables anymore. We have processed and we have ultra-processed food. They've learned how to take food that is unripe and store it, and then if you give it a shot of ethylene gas, it will ripen. Now you can do this if you have an unripe banana, put it in a bag with a slice of apple, because the apple will release the ethylene gas, and you'll ripen it up a little faster. So we've now reached the point where we have excess calories for the first time in the history of humans, and that's led to a problem of worldwide obesity. And as I tell people when I was in practice, my patients would ask me, "Doc, don't you have a pill that will let me lose weight? I don't want to go to the gym or go on a diet. I want this magic pill." Well, now we've got it, Wegovy or Ozempic. And interestingly enough, there are some patients where their mental whatever overrides the effect of the drug. And so, but for most people, it does seem to work. It's a GLP-1 um, process, so it interferes with their hunger, and we eat less because of it. But keep in mind that the food we have today is really a tremendous improvement over what we used to have. We know how to make it more nutritious, we make it more available, and we kind of take it for granted without realizing what's going on behind it. Some of the technology that we've developed to store it, to preserve it, and to improve it. So thank you very much. If you have any questions, be glad to answer them. Okay, Barbara?
Hi. Our first house in Miami was around the corner from a strawberry field. And I can tell you there's a big difference because in February or January, when they were, Florida strawberries, they were absolutely delicious. And now, they're not bad, but they certainly don't taste the same.
Well, you see, the problem is if you've had the experience of getting really fresh food, like going to a farm or picking a fresh strawberry or eating a peach off the tree, you know that we don't have that quality of food today. And that's the trade-off. If you're going to ship it or preserve it, you can't keep it at the peak of freshness. Now, one of the problems we have is the vegetables that are grown in Mexico are picked ripe as a rule. And so they're better. They taste better than a lot of the other vegetables you have on the market. I think as of this next week, you're going to pay 25% more because we've got a tariff on everything coming in from Mexico. It's what? Midnight tonight? Sorry, you better shop now.
It's already too late. They've raised the prices.
They've raised the prices.
I just wanted to add on a little bit to your thing. I don't know if we call them foods, but there are whole departments in medical schools of alternative medicines, but mostly in addition to regular medication, like red yeast rice for cholesterol and various fungi for neuropathy, and a lot of these have been originally looked at from Chinese medicine and then gone and examined and tested and so forth. But it's very interesting.
You know, most of our drugs come from plants, and they don't make these compounds to help humans. They make them to keep them from being eaten by other animals. But you talk about Chinese medicine. Eve and I were in China, and she developed a skin rash. So we went to a Chinese doctor who wrote a prescription. We went to the pharmacy where we got this tube of stuff with all the Chinese herbs. And of course, the blurb that came with it was in Chinese, except for one word, dexamethasone. So they're willing to use modern medicine in addition to their classic herbal medicine.
Joe, do you know if all the yellow rices are beta carotene, or do some of them have artificial color?
Well, some of the rice, you put the saffron in it to make it yellow, but the so-called yellow rice has beta carotene. So I don't know, I mean, a lot of the yellow rice today you'll see is regular white rice with some coloring in it. But for the Asians, they needed the vitamin A. And so they developed this rice with the beta carotene.
I think you're saying no.
Well, probably no, yeah. The other thing is we've developed a lot of other things that, if you have salt, it has iodine in it to prevent goiter. Or if you look at your milk, it's vitamin A and D fortified. Your flour has folic acid and has other things in it. So we've incorporated these things into our food.
Any other question? And I
Oh, well then, thank you very much.
Thank you, Joe.